Hi, ladies and gentlemen. Today we're going to be working on dividing numbers with exponents. I'm going to get rid of my picture. Sorry about that. All right, so if you notice, number 1 is 2 to the 5th divided by 2 to the 2nd equals 2 to the 5th over 2 to the 2nd. So they're just rewriting it vertically here. And then we have expanded form. 2 to the 5th is 2 times 2 times 2 times 2 times 2 over 2 to the 2nd, which is 2 times 2. What happens here is you have, if you picture 2 divided by 2, what's 2 divided by 2? That should be equal to 1. So if you think about this, 2 divided by 2, this 2 divided by this 2 equals 1. This 2 divided by this 2 equals 1. So if we have 1 times the rest of this, remember, like 1 times 2 is still 2. So if we have 1 times 1 times 2 times 2 times 2, it's still just 2 times 2 times 2. So basically, I'm saying this because these 2's will cancel each other out, in other words. So then we have our exponential form of what's left. So we have 2 to the 3rd power, because there's 3 2's. Number 2, we have 4 to the 6th, so we're going to have 1, 2, 3, 4, 5, 6, and all of these are going to be multiplied times each other, divided by 4 to the 2nd, so 4 times 4. Again, these 4's, a 4 on top and a 4 on the bottom cancel out, a 4 on top and a 4 on the bottom cancel out. We're left with 4 4's on top. So 4 is our base because that's what's being multiplied, and we have 4 of them. That's your exponent. Number 3, we have 5 times 5 times 5 times 5 times 5, 1, 2, 3, 4, 5 times 5. There's 6 5's over 2 5's. 1, 2. 5 cancels out with 5. 5 cancels out with 5. I'm left with 4 5's. 4 5's. So I'm going to skip number 4 and number 5, and I want to move down here to some variables. So we have r to the 4th, 1, 2, 3, 4, over r to the 2nd, r to the 2nd. So we can cancel out an r with an r, an r with an r, and we're left with 2 r's on the top. So r to the 2nd. Let's look at number 7. Number 7, we have 7 s's on the top. 1, 2, 3, 4, 5, 6, 7. Again, these are all being multiplied. And we have 3 on the bottom. 1, 2, 3. 1 s cancels with 1 s on the top and on the bottom, top, bottom. We're left with s to the 4th because there's 4 s's left. Hopefully you can see the pattern as of now. If you notice, they are with the canceling. In other words, we are subtracting. So notice 7 over 3, or 7 divided this, sorry, I'm looking at this one. 7 minus 3 gives me 4. 4 minus 2 gives me 2. 6 minus 2 gives me 4. So these other ones, number 4, number 5, number 8, without having to expand it, I can see that the base is going to be the same, and then I'm going to subtract the exponents. The bases are going to be the same. Oops, that's a 10. And I'm going to subtract these exponents. 7 minus 4 is 3. Number 8, the base is going to be the same, so we have an m. And we're going to subtract these exponents. 10 minus 3 is 7. So if we look down here at our rule, we can write a rule just like we did when we were multiplying. And let's see. We're going to write a rule just like we did when we were multiplying. So when dividing powers with the same base, again, I'm going to capitalize that because they have to have the same base for this rule to work. When dividing powers with the same base, we're going to keep the base and subtract the exponents. Again, when dividing powers with the same base, keep the base and subtract the exponents. I would like for you to try. Let's see. I'm going to write a couple right here for you to try. And then on the back side of your paper, go ahead and write a summary and some questions or a question. So let's see. We're going to try a couple here. So let's try, this is you try. Let's try, another example. Let's try another example, sorry. I'm going to erase this because I'd like to try an example with a coefficient. So let's try 12x to the 5th over 6x to the 3rd. Go ahead and pause the video and you try it. So this 12 over 6, just like our coefficients when we were multiplying, we could multiply those coefficients. Well, here, the coefficients, we're going to divide like normal, and then we're going to use our rule for our exponents, for our powers. So 12 divided by 6 is 2. And then x to the 5th over x to the 3rd, I'm going to keep that base, and I'm going to subtract 5 minus 3, and that gives me 2. So this gives me 2x to the 2nd. What if I had, let's do another example. What if I had, let's see, 16y to the 5th, z to the 3rd over 12 y to the 2nd z. So again, I can simplify or divide my coefficients like normal. This one, 12 doesn't go into 16 evenly, like 6 went into 12 evenly. So this one I'm just going to have to simplify and keep it as an improper fraction. So let's see, 4 goes into both of those. 16 divided by 4 is 4. 12 divided by 4 is 3. Then I look at my like bases. I have y to the fifth over y to the second. So that's going to give me y to the third. 5 minus 2 is 3. I have like bases here, z to the third over z to the first. 3 minus 1 is 2, so I have z to the second. If you think about this, if we're thinking about canceling z's and y's in this example, we have more y's and more z's on the top of our fraction rather than on the bottom. So all of the y's and the z's on the bottom canceled out, which is why in our answer we don't have any y's and z's on the bottom. All right, don't forget your summary and your questions, and we will practice more of this in class.